Hello and welcome back to the channel. So in this video we'll be covering a different example, an example which is again very popular in the exams or the midterms that you usually get in your integral calculus courses. So this question is usually based on illustrating the area given by a following Riemann sum. So in these type of questions you'll basically get a sigma notation which would represent your Riemann sum sigma notation, and you basically have to identify the function fx, and then after identifying the function you have to draw a picture illustrating the area given by the following Riemann sum or by the following function based on the given endpoints that you'll calculate in this question. So in order to solve this question specifically, there are multiple ways in which you can solve this question, multiple easier ways in which you can solve this question, but I'll follow the most general approach to solve this question so that you can also apply this general approach in the other similar problems that you will get in your final exam or in your midterms as well. So we'll start with, I've written down some steps which you have to follow, or you'll basically follow in order to get to the final solution. So the main thing about this question is to identify my function fx and then identify the endpoints. So if I have the function and the endpoints, I'll easily graph my function based on the endpoints that have been given or that I'll calculate in the question. So in order to first solve this question, you'll first write the prototypes of a Riemann sum and expand on the components of the Riemann sum, just as we did in the last video. If you have not watched the previous video, I would highly suggest you to first watch that video in order to get the full context of this question. So in the first step, you'll write the prototypes of the Riemann sum and expand the components of the prototypes of the Riemann sum, and then based on the prototypes you'll find a pattern. And observe the values a, b and n. And once you have calculated the values of a, b and n by observing the pattern, you'll find this occurrence. You'll find the occurrence of a plus I delta x, which would be a right Riemann sum notation, or you'll find a pattern which would look somewhat like a plus I minus 1 times delta x, which will represent a left hand Riemann sum. And then once you have found this occurrence, or once you have found this pattern in your Riemann sum, you'll replace every occurrence of this pattern with just x, and by replacing every occurrence of this pattern with x, you'll basically get the function fx. And after you've got the function, you already know the endpoints, so you'll easily be able to sketch the graph of the function based on fx and the endpoints given, right? Don't worry if all these steps sound confusing. We'll cover each and every step in detail when we'll solve this question. So let's move on to solving this question. And the first step, we have to write the prototypes of what a Riemann sum looks like, right? So we'll write, so a Riemann sum looks like a sigma notation which starts from, I'll use I in this case because they've used I in this case. So a sigma notation I equals 1 to n fxi delta x, where my xi is either this or this. So in this case I'll write the right hand Riemann sum notation in order to simplify everything. You can also use the left hand Riemann sum in this case, but it would make your answer a bit more complex than what you would get with the right hand Riemann sum. So my xi is basically a plus I delta x, and my delta x is b minus a by n, right? So now since we have written all the prototypes, we have to find a pattern in order to solve for a, b and n. So I'll just move this sigma notation over to this side and we'll compare both of those sigma notations. And when I'll compare both of these sigma notations, I see that my n is equal to 3 and my delta x is equal to 2. And my xi in this case is equal to 5 plus 2i. Right? So now I've written all the components which I visually see with just comparing both of those sigma notations. So my step 1 is done. My step 2 is to find the pattern in order to solve for a, b and n. And I clearly see my n is 3, my delta x is 2 and my xi is this. And if I write my xi again, above this expression, above the general expression of xi, I see this thing. Right? So if I now compare both of these xi's together, I can clearly see that my a is 5 and my delta x is 2 again. which confirms the previous result as well. So now I see that I'm on the right track. I've identified this pattern. I've identified a plus I delta x, which is 5 plus 2i in this case. So now after following the last step, I'll replace every occurrence of 5 plus 2i in this case and change it to x. So my final expression, which is this, would look somewhat like sigma I goes from 1 to 3 x square delta x, because my original expression was I equals 1 to 3 5 plus 2i square times 2. And we can also confirm this expression from the above results as well, because my delta x was calculated to be 2, so I replaced 2 with delta x, and I've replaced every occurrence of 5 plus 2i, which I calculated in this case, and replaced every occurrence of 5 plus 2i with x. So this is the final expression that I get after replacing every occurrence of my a plus I delta x and changing all those values. So now, since I also know that this is my fx, the thing that I got over here is my fx, I can easily write my function. So my function is just x square. And I've also got my endpoints as well. I've got my left endpoint a as 5, my delta x is 2, so b minus a upon n is 2, and my n is 3. So if my n is 3, I can substitute those values. B minus a becomes 2 times 3, b minus a is 6, and since my a is 5, my b becomes 11. So now I have my b, which is my right endpoint, I have my a, which is my left endpoint, I have the number of subintervals, n equals 3, so I can just sketch the graph of this function, because now it just becomes the approximation of area under the curve of x square bounded between x equals 5 and x equals 11. But in addition to everything else, I also have to consider one important fact, that when I was taking xi, since I took xi to be a plus I delta x, this is my expression for a right hand Riemann sum, and this is the fact that I'll have to consider while drawing the sketch of the area given by my following Riemann sum. And based on all the calculations that we did so far, our final sketch would look like this, where I have taken the right hand Riemann sum of the function y equals x square bounded by the intervals x equals 5 to x equals 11. And since this is a right hand Riemann sum, my height of the last rectangle should be equal to the value of the function at the right end point. So that was it for today's video. I hope you found it interesting. If you have any doubts, feel free to comment down in this video. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching, and bye bye.